If you're watching this video, you are probably very familiar with Comet 3I Atlas. It's hard to escape all of the information that is out there. A lot of claims, but there's a lot of science, and it is a very weird object. It is unlike anything we have ever seen here in the solar system. Something that has spent millions, maybe even billions of years floating through the cosmos, and it arrived here in our solar system. It's giving us a unique chance to understand the composition, the formation of objects that come from entirely different star systems. It saves us all the trouble of having to build a spaceship to go to another star system. The universe is sending this stuff to us. At Universe Today, we've been doing a ton of reporting on Comet 3I Atlas. We have dozens of stories on the website about this incredible object. And so in this video, I'm going to tell you everything we know about this comet so far, what happens next, and how we could take advantage of other interstellar objects in the future to learn about other star systems. I'm going to reference the actual astronomers who have been making the observations, the telescopes that they used, the methods that they gathered their information, and we're going to put links to every single one of the papers in the show notes down below so that you can follow and do your own research to learn more. And of course, we're going to address the elephant in the room, the paper by Avi Loeb, the controversy here on YouTube that people are making claims that it's an alien spacecraft. You know, it's something that I can't ignore. If you just want to hear about that, you can just go to that chapter in this video and watch that now. Otherwise, stick around for the science and all of the papers that have come out. So Comet 3I Atlas was first discovered on July 1st, 2025. It was announced by Daryl Seligman and his team. This is the third interstellar object. Atlas is the name of the telescope that discovered it. It's the Asteroid Terrestrial Impact Last Alert System. This is a telescope that is scanning the sky every night looking for objects that are moving. And so it finds a lot of comets and asteroids and has many of them named after it. Seligman and his team identified this object moving through the Atlas images and realized that it had a very high velocity and suspected that it was an interstellar object. And so they did follow-on observations with the Canada-France-Hawaii telescope and the Very Large Telescope. And from there, they confirmed that yes, indeed, this is an object that came from outside the solar system. And this was blindingly obvious, mostly because of its speed. It has a hyperbolic velocity of 58 kilometers per second. This is the fastest ever seen and well beyond the escape velocity of the sun. In other words, this object is going to blast through the solar system and then continue on out into the Milky Way. It has an inclination of 175 degrees compared to the ecliptic, and that's about 5 degrees off of the Earth's orbit from the sun. So it's very similar to the orbit of the rest of the planets in the solar system. And that is surprising. Of all of the angles that it could have come in on, that it chose this one. And just for comparison, Oumuamua, which was the first interstellar object ever seen, was about 400 meters across and very cylindrical, very long compared to its width. The second object, Borisov, was about 975 meters across, while this one is much bigger. Estimates put it between 5.5 and 10 kilometers across. Speed, Oumuamua was the slowest, going through the solar system at 26 kilometers per second. Borisov was moving at 32 kilometers per second, and 3I Atlas is going at 58 kilometers per second. More than twice as quick. And while the previous interstellar object, Oumuamua, had very significant changes in its brightness, 3I Atlas didn't change very much, which means that it was probably more spherical in nature. So then we had a series of telescopes from around the world and in space turning to gaze at this new interstellar object. For example, the 10.4 meter Grand Telescope on the Canary Islands. In a paper published by R. de la Fuente Marcos and others, they found that it is much redder than other interstellar objects. It is much more similar to a D-type asteroid than a Kuiper Belt object. And they were able to calculate its rotation period at 16.79 hours. And they concluded that it had similar chemical composition to objects that come from beyond the asteroid belt, but not all the way out into the Kuiper Belt, which we'll get into in a bit. But it turns out with that initial discovery, astronomers looked through archival data and realized that they had already seen it And the best example of this is the Vera Rubin Observatory, which was in the process of its provisioning phase, where they're testing out the optics. It happened to be looking at exactly the spot in the sky where 3I Atlas was moving. In a paper from Colin Ryan Chandler and others, they looked through archival data from the Vera Rubin Observatory and realized that they had 37 separate images of the comet moving through their field of view. And then astronomers working with the Transiting Exoplanet Survey Satellite, or TESS, realized that the comet had been moving through their field of view in the region that the mission was looking for exoplanets, and that they had been seeing it continuously from May 7th to June 2nd. And from TESS, they were able to make estimates of its size, bringing it down to about 5.4 kilometers across. But even as early as May, several months before its discovery by Atlas, it was already starting to exhibit comet-like behavior at a distance of about 6 astronomical units. So that was the discovery and the pre-discovery. And then both the ground and space-based telescopes all turned to focus on this comet and try to figure out more about it. There were observations from the Canada-France-Hawaii telescope, the Very Large Telescope, the Kotamia Astronomical Observatory, the Palomar 200-inch telescope, the Apache Point Astrophysical Research Consortium, the Grand Telescope on the Canary Islands, NASA's Infrared Telescope Facility, the Gemini South Telescope, the 3.8-meter Seimei Telescope. But there were some very interesting observations made with some of the biggest telescopes. In a paper from Bin Young and others, using the Gemini South Telescope, they gathered data between July 5th and July 14th, which was very early on after that initial discovery. And they saw that it had the color of a D-type asteroid. So think of like Phobos with a more reddish color and a very low albedo. And we actually have a meteorite here on Earth that had a very similar composition to what they were seeing, the Tagish Lake meteorite, which fell near the turn of the century in Canada. And then on August 4th, the Hubble Space Telescope was turned to look at 3I Atlas. In a paper from David Jewett and others, they were looking at the comet when it was at 3.8 astronomical units away from its perihelion, or its closest point to the sun. And they were able to observe the coma around the nucleus of the comet and calculate that it was losing between 12 and 120 kilograms per second of material sublimating off of its surface. But one of the strangest observations was that it had an anti-tail, a tail of material that was pointing towards the sun. And this is a bit of a mystery, but there are some explanations for what this could be. When the comet is that far up from the sun, it's starting to get heated up by the sun's radiation, but it's too far away for the solar wind to really impact it. Until the side that's facing the sun starts to sublimate, material comes off of the comet and starts to drift towards the sun. And they also confirmed the nucleus to be around 5.5 kilometers across. But it really depends on what is the molecule that is contributing to this coma. It could change the size of the comet. And then, of course, the James Webb Space Telescope was called on to take images of Comet 3I Atlas. On August 25th, Martin Cordiner and others gave their findings with Webb. And it revealed a carbon dioxide dominated coma, with a ratio of carbon dioxide to water of 7.6 to 1. This is the highest ratio of carbon dioxide to water that has ever been seen in a comet, and is one of the strongest clues about the formation and origin of Comet 3I Atlas. It likely has a carbon dioxide rich nucleus, which is not something that we see comets here in the solar system. Now, why is it giving off this much carbon dioxide? One possibility is that it's experiencing unusual amounts of radiation that far out in the solar system, or received a bunch while it was in interstellar space. And the other possibility, and this is the really intriguing one, is that it formed in its own star system at around the carbon dioxide frost line. We have a water frost line here in the solar system, which is sort of in the middle of the asteroid belt, and then a carbon dioxide frost line, which is much farther out in the solar system. And so maybe this object formed at that place where even the carbon dioxide doesn't sublimate from radiation from its star. But this is not a thing that we see in the solar system. And they also confirmed this plume of dust going in the sunward direction. And then on August 25th, Rohan Gankar and others used the Very Large Telescope to analyze its coma and its glowing tail. And this is one of the other really bizarre discoveries that was made, which is that they discovered the presence of nickel in the coma around the comet, but not the presence of iron. They also detected the presence of cyanide. Now, cyanide is common. There was a great scare back in 1910 when Halley's Comet was passing through the solar system, and astronomers had just developed the technique of photometry. They were able to measure the chemical fingerprint of Comet Halley, and they detected the presence of cyanide. And so people were worried that cyanide gas was going to poison them on Earth, which of course it didn't. But this was the kind of conspiracy theories that were forming about comets more than 100 years ago. So how are you getting nickel in the coma of the comet? Now, you're not getting it directly sublimating off of the surface of the comet. It's not hot enough, not deep enough into the solar system for that to start happening. Instead, it's likely that there's nickel mixed in with other organic compounds on the surface of the comet. Those compounds are sublimating off the surface of the comet, and then these organic molecules are breaking up and you're getting this nickel mixed in with the coma material. But where was its tail? Although we had seen activity of the comet for several months, we still hadn't seen its tail. But then on September 4th, we got new images from the Gemini South Observatory, and there's the tail. At this point, it's only 120th of a degree in the sky, really only visible in the largest telescopes. There were some interesting things that happened to it. It was potentially hit by a coronal mass ejection, not that that seemed to have done anything to the comet. And from the orbit of the comet, astronomers were able to make some really interesting calculations about where it might have come from. So the first paper on this came out almost immediately from Matthew Hopkins and others, and they calculated the trajectory of the comet and estimated that it came from the thick disk of the Milky Way, a region that is metal poor. And they predict that it's probably around 7.6 billion years old, which would make it the oldest object that has ever been found in the solar system. Everything inside the solar system formed with the sun 4.5 billion years ago. And so here's something that is billions of years older than anything we have in the solar system. And then on September 9th, X. Perez Couto and others calculated the historical journey of Comet 3I Atlas. Did it really come from the region that had been estimated? They wanted to know if various stellar flybys throughout its history could have changed its trajectory very much. And they were able to find 93 encounters with stars throughout 10 million years of its history. But when they added up all of those encounters, they found they were minimal. The closest encounter was about 0.3 light years away from another star and only ended up changing its velocity by 0.5 meters per second, which is insignificant. And they estimated that the age of the comet is somewhere between 3 and 11 billion years old. And again, came from a system which has a low metallicity, which matches this observation that it has a high amount of carbon dioxide relative to water in it. During its flight through the solar system, Comet 3I Atlas was expected to make a few close flybys. The first close flyby on October 3rd, it came within 0.19 astronomical units of Mars. On October 29th, it comes within 1.36 astronomical units of the Sun. On November 3rd, it comes within 0.65 astronomical units of Venus. On December 19th, 1.8 astronomical units of the Earth. And on March 16th, 2026, it comes within 0.36 astronomical units of Jupiter. And so for this Mars flyby, we have a fleet of spacecraft at Mars ready to see as it comes by. We have rovers on the ground, spacecraft in orbit around Mars. But there's a problem. And that is the US government shutdown means that none of the teams are working with the spacecraft. And so we were lucky to get some images from Perseverance, but we don't know when we're going to be able to get the images from the Mars Reconnaissance Orbiter, which has the best telescope in the system. But we did get images from ESA's ExoMars mission, and they're trying with the Mars Express spacecraft. So on October 3rd, NASA's Perseverance rover looked up into the sky and looked at the region where 3I Atlas was moving through the sky. It took 20 30-second exposures, and then Simeon Schmaus painstakingly went through the raw images and stacked them up to give us this image of Comet 3i Atlas moving through the sky on Mars. ESA's ExoMars mission started making its observations on October 1st, wrapping up on October 7th. At the closest point, it was about 30 million kilometers away from the comet. ExoMars was able to make a series of half-second exposures of the comet, and then the European Space Agency was able to stack those images and produce this image of the comet moving through the field of view. Now, it wasn't sensitive enough to distinguish the nucleus from the coma, but still you can see the tail and you can see it moving. And ExoMars was never designed to do this kind of thing. It's used to looking at objects that are 10,000 to 100,000 times brighter than Comet 3i Atlas. And we know that ESA's Mars Express spacecraft was also trying to make observations. Normally, it's looking down at the surface of Mars, taking pictures of bright terrain on the surface, but it is able to look at objects in space. It's taking pictures of Phobos and Deimos, but it can only do half-second exposures. It can't do the 5-second exposures that the ExoMars mission can do. And so far, the European Space Agency says they just haven't been able to resolve the comet in their images. So we're going to have to wait until after the government shutdown in the US to see the images taken by the Mars Reconnaissance Orbiter. It has a half-meter telescope. It can take these kinds of images. At the time that I'm recording this video, the time you're probably watching this video, Comet 3i Atlas has now gone behind the sun. And we're going to wait for it to reappear on the other side so that we can continue to take images of it. Some of the most interesting things that it's going to do are only going to be seen by spacecraft that are on the other side of the sun from us. For example, the European Space Agency's JUICE mission is going to be able to see it in early November before we'll be able to see it from the Earth. Although it's pretty far away, it will be seeing it at this rate of highest activity and maybe see the longest version of the tail. And according to a paper from Marshall Eubanks and others, the JUICE mission will actually fly through the tail of 3i Atlas. I'm not sure it'll be able to detect anything in the tail, but they'll try. An interstellar object passing through the solar system is an incredible opportunity for us to examine an object that was formed in another star system. But their paths through the solar system come randomly. You never know where they're going to be. But what if we could do a flyby of one of these objects? The European Space Agency is planning a mission in 2029 called the Comet Interceptor mission. It's going to launch in 2029, fly out to a parking orbit, and then wait for a target. Now, that could be a long period comet coming from the Oort cloud, or that could be an interstellar object. Then it'll fire its thrusters and put itself on an intercept course with that object and do a very close flyby. And that'll give us a better view than any of these telescopes, any of these spacecraft that we've had so far. And scientists at the Southwest Research Institute are developing a concept for an interstellar object analysis mission that could fly past a future interstellar object as well. If this mission was in space right now, it could have done a flyby of 3i Atlas. It's led by Alan Stern, who's the principal investigator of the New Horizons mission. We'll get one last chance to observe it as it goes past Jupiter with the Juno mission, but it won't be very close, and most of its activity will have died down at that point. All right, let's address the elephant in the room. Is it an alien spacecraft? Well, there's no evidence to believe that it is. Now, you can never rule it out. It could always be an alien spacecraft, but if you're going to make the claim that it is an alien spacecraft, you've got to have some kind of evidence that says that it's that other than mere coincidence. I've covered more than a dozen science papers here in this video, but one science paper comes from Avi Loeb, and he is proposing that this is in fact an alien spacecraft. He's also been writing on his blog all of the interesting, unusual, anomalous behavior that this comet is experiencing, and recently gave it a 30 to 40% chance of being an alien spacecraft. He identifies 9 anomalies that indicate that it's an alien spacecraft. For example, how large it is, the chemical composition of its coma. 4 of these criteria he assumes are going to be better understood with upcoming observations with telescopes, but 5 of them can't be explained. For example, the fact that it's coming in very close to the plane of the ecliptic, that it's going to make relatively close flybys of Mars and the Sun and Jupiter. But these can also be explained by coincidences. None of these are things that a comet can't do. They're just a collection of interesting features of this object. And if you're going to make a claim that this is an alien spacecraft, you have to identify things that it's doing that comets and asteroids just can't do. So there was a paper that came out from James Davenport and others, and they talk about 4 different criteria that you would expect to see if it's not just a comet, something more like an alien spacecraft. For example, you'd be looking at an anomalous trajectory. If it started to decelerate heavily in a way that a comet just wouldn't do it, or if it had an anomalous spectra or colors, if it was purple, if it was made of chrome or carbon fiber or some other material that you wouldn't expect a comet to be made of. It could have an anomalous shape. Instead of being roughly a sphere or a rubble pile, it could be shaped like an arrow or shaped like a triangle or shaped like a bored cube. Or it could give off some kind of transmission, like radio signals that you would not expect to see coming from a comet. Those are the kinds of lines of evidence that you would want to see to be able to support the claim that it's an alien technology. And this is just a fraction of the papers that have been coming out about 3I Atlas. These are the big ones. There have been a lot of others as well. Although the scientific community disagrees with Avi Loeb and the claims that he's making about the nature of 3I Atlas, there are a lot of people here on YouTube that are making completely baseless claims. They're just jumping on the bandwagon. They're taking part in this excitement over this object, and they're making a lot of really baseless claims with no scientific underpinnings of what they're saying. And the problem is that it's really hard for people to know what is good information, what's bad information. So my hope is that you can go and you can look at all of these different journal papers and you can follow these and understand the sources that I'm quoting for the things that I'm saying about this comet. And I will continue to do that as we move into the future. All right, so we've reached the intermission of our observations of Comet 3I Atlas. It's now gone past Mars. It is making its way behind the sun from our perspective. We're gonna have to wait until early November when it finally appears from the other side of the sun, and the observations will continue. We will learn as much as we can about this comet until it fades away off into the cosmos, maybe to go visit another star system. I'm going to share some final thoughts, but first I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nelson, David Veribath, David Gilson, David Matz, Evan Pro, Greg Feely, Hudson Ward, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Spitz, Michael Purcell, Modzo, OneStepForAnimals.org, Paul Robach, Rain Kaidu, Richard Williams, Sean Sargent, Stephen Fallon-Lemonley, Team 49, Telescopes Canada, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. I've been doing this job for a long time now, 26 years. And during this time, we have learned about 3 of these interstellar objects. Each one is special and different and offers this incredible perspective on another star system. And thanks to the Vera Rubin Observatory, which is just in the process of coming online now, we're going to get many more observations. It's expected we're going to learn about more than a dozen of these objects every single year. We've got spacecraft in the works from the European Space Agency. Other space agencies are planning them as well. We will eventually have close-up images of interstellar objects. Then comes landers, then comes sample return missions. And so we've got this incredible opportunity. The universe is sending us material, sending us care packages of asteroids and comets that were formed in other star systems, allowing us to learn about their histories. Instead of us having to build an interstellar spacecraft to go to another star system, interstellar objects are coming to us. All we have to do is be ready to study them. It's going to be a fascinating time, and the best is yet to come. All right, we'll see you next time.